Anyway, okay, so let's see though, how does it work? So we're going to put, let me do this right, that, and that, okay, and that, and that, and that, and that. Okay, so we have these what are called weights. And then we're going to have the same thing here. I'll just use the same set. So I'm going to say one here, and one here. Okay? Now we're going to put, okay, so I said, for example, we're going to put 4 here and 7 in there as starting point. Okay, now these weights are going to be different numbers. So let's say we had a weight of 2 here and 3 here. These are just arbitrary numbers I'm putting in here. And 3 here and 1 here and 2 here and 1 there. Okay, so what happens is we take the 4 times the 3 and we take the 7 times the 1 and we put that in here. We add them up. So I take the 4 times the 3 and the 7 times the 1. So that's 4 times 3 plus 7 times 1, and that's what goes in here. Okay, this seems strange to do, but it works. Okay, then what goes in here? Can you see what I'm saying? Can you see what goes in here? So 7 times 3 and 4 times 2, right? And what goes in here? 4 times 2 and 7 times 1, right? So first of all, we get 12 plus 7 is 19, right? Is that right? So we get 19 here. And what do we get here? 2 times 4 and 3 times 7 is 8 plus 21 is 29, right? We get 29 here, we get something else here, right? And then we're going to have weights here as well. So we're going to have like some other weights, like 1, 2, 3, for example. Yeah? You're learning neural network? Oh, the same graph, but it's supply chain. Okay, good, yeah. That's right. It's a graph. It's called a graph in graph theory. It's called a graph. And you have different layers like this. You have exactly the same thing? Interesting. Actually, I don't know anything about supply chain, but okay. All right, anyway, what goes here? So 1 times 19, 2 times 29, and 3 times this one, right? You add them up, and you get something in here, right? Okay? Everyone see this? Okay, now, what happens is, we do one more thing usually. We don't just leave this 19. And they probably don't do this in supply chain, we transform this number. We want to transform it so that it's only going to be between, I think we're going to transform it so that it's only between 0 and 1. Okay? So we're going to use this kind of curve. This is called, oh, sorry, I didn't do that right. It's like, I didn't do that very well. Let me try it again. Okay. Something like that. So this is 1 and this is 0. Okay, so what I mean is, if I'm going to put in this 19, right? 19 was here. So 19, when I put it into this curve, is going to be quite close to 1, right? If I put in, let's say this was only 2, right? Then 2 might be here, not going to be as close to 1. Okay, so I'm going to transform these by putting them into this function, which is called an SCurve, or called a sigmoid curve. Okay, so I'm going to put them in here. So what's going to, this isn't going to be 19 after that, it's going to be something between 0 and 1. Okay, this isn't going to be 29 anymore, it also could be something between 0 and 1. Okay, so there are reasons to do this. It seems to make the whole thing perform better. Okay, it gives it much more flexibility for some reason, because actually this is basically just a linear function, right? That's basically just a linear, but this is not linear. So when you allow for nonlinear stuff, you get more power. Okay? So anyway, we have this. All right? Everyone following me so far? So let's say this isn't going to be 19, it's going to be 0.8, and this is going to be 0.9, and this is going to be .3. Okay? So then we're going to take 0.8 times 1, 0.9 times 2, and 0.3 times 3. And that's what's going to go in here. Okay, does this make sense? But actually we're going to take what's in here, and again we're going to do that same thing to it. Okay, we're going to squish it into this. We say squish it because it's now going to be pushed between 0 and 1. Okay, I'm going to limit it to 0 and 1. So whatever I get in here, I'm going to put that in here, and then I'm going to get something out, right? Everyone understand? And what I'm going to get out is going to be between 0 and 1, right? And that could be some prediction of what your grade is. Remember we said your grade is a percentage, right? So this is going to be a prediction of what your grade is. Now it's not going to be a good prediction. There's no reason it should be good. We just arbitrarily put these numbers in there. This number, and 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 this number. We just put them in arbitrarily. So there's no reason to believe it's going to give a good prediction of your score, right? But we're going to have some method for measuring how much of an error we made. What do I mean by the error? I mean, well, let's say this predicted that you're going to get a 62, right? But you actually got an 89. Okay, so what's the error? It's this minus this, which is what? 27, right? No, 17. Wait, what is it? 27. Right? The error between these two is 27, right? 0.27. So that's an error, right? Now that error is how this network is going to learn. So when we put in the 4.7, we're going to get an error, right? Some kind of error, probably. It's not going to get it perfect. And when we put in the 3.8, we're going to get an error, right? And when we put in this, we're going to get an error. And we're going to take those errors and we're going to use them to adjust these weights. And we do it in an intelligent way using the derivative. The derivative of something here is going to allow us to adjust these weights. So it's the derivative that does this. And not only is it the derivative, but we need the chain rule. So we studied the chain rule, right? Right? We talked about the derivative of certain kinds of functions where we needed the chain rule, right? It's exactly that teaches this network how to adjust these weights. Now, you have to go through the detail. You have to see that doesn't make sense, right? Just saying it's the derivative, you don't know what I'm talking about. But it is exactly and only that allows us to adjust these weights. So what we do is, we don't just put in 3 of these, we put in 30,000 of these different rows of data. So here's one example of data. Here's another example, or actually this is one example of data. This is another example of data. This is another example of data, right? We're going to give it 1,000, 10,000, 100,000 examples. It's going to learn from those examples by doing this derivative each time, going to adjust these weights each time. Each time it's going to get a little bit better, hopefully, at making predictions. And the more examples you give it, we say the more examples that you train it with, the better it gets. And that is exactly, and that is the whole thing for what a neural network is. Okay, and it's up to you to do the math. And the thing is that the math is not a derivative like this anymore. It's a derivative where we have 2 inputs, or actually we have many inputs, sorry. For every weight, that's considered So we're not going to actually, the things that we want to change are the weights. So we're going to think about the derivative of something with respect to the weights, but there are many weights. So we have basically a function of all these weights, weight 1, weight 2, weight 3, many weights. And so that's more complicated than just a function of one variable. So what you need to do is study calculus of multivariate calculus. But it's still the same thing, it's still derivatives. Just how do we do it when we're talking about more than one input? Okay? So now also in this video, he shows us the programming for it. So he uses the programming language Python. So he's going to say, let's set this up in Python. So it means we're going to have, this is be a matrix of values that are going to be the input, and we're going to have a vector of outputs. Okay? So you have to create that in Python. So he's going to do that. He's going to say, let x equal these, these numbers. But in Python, you have to do that in what's called an array. Okay, so that you have to do like this, 4, 7, comma, 3, 8, comma, 5, 4. Okay, so that's how you have to set that up in Python. Now you'd have this input array. Okay, and then you'd create a vector, you can, with these values. Okay, and that's going to be called y. Okay, so you're going to have an input, just like, when we say y equals f of x, right? So, but our x is going to be this big X of all these inputs, and y is going to be these outputs. Okay, anyway, I'm going at the speed of light here, instead of going through it step by step. So we do it step by step in the course called Special Lecture that I'm going to teach next semester, and the course called Data Mining, and the course called Intro to Programming, which is Python. Okay? But let's just see what he does. Let's just go through a little of it and see what it looks like. And I'll stop it in the middle. So this is what? Yeah, it's the same.
They just say that it collects more data because it's not as private as Siri, for example.
Yeah, Siri is more private, but Google is probably not private. I think Siri, Apple is private. Okay, so anyway, let's look at this. So, this set of videos is called Neural Networks Demystified. And they're quite short.
If you write anything on your computer, you need to get grounded.
I write pretty much all day, every day, and Grammarly makes my writing better.
Let's say you want to predict some output value y given some input value x. For example, maybe you want to predict your score on a test based on how many hours you sleep and how many hours you studied the night before. To use a machine learning approach, we first need some data. Let's say for the last 3 tests, you recorded your number of hours studying, your number of hours sleeping, and your score on the test. We'll use the programming language Python to store our data in 2-dimensional NumPy arrays. Now that we have some...
Okay, can you see he stored x and y. And this was the x data, and this was the y data. And then he just printed it out to make sure it looks right. So he said x, and this is what we get, which is 3551102. And y, he prints it out, he gets this. Okay?
data, we're going to use it to train a model to predict how well you will do on your next
So he
test.
calls it training a model. That's what we're doing. We're training a model. And we're going to use it to predict what's going to happen when you sleep 8 hours and you study 3 hours.
test based on how many hours you sleep and how many hours you study.
And this data here is in the data science, this is called the training data, and this is called the testing data, sort of.
This is called a supervised regression problem.
Okay, regression means that, the word supervised is not necessary, but the word regression means that we're not predicting your letter grade, we're predicting a number. Okay, letter grade would be something different.
It's supervised because our examples have inputs and outputs. It's a regression problem because we're predicting your test score, which is a continuous output. If we were predicting your letter grade, this would be called a classification problem and not a regression problem. There are an overwhelming number of models within machine learning. Here, we're going to use a particularly interesting one called an artificial neural network. These guys are loosely based on how the neurons in your brain work and have been particularly successful recently at solving really big, really hard problems. Before we throw our data into the model, we need to account for the differences in the units of our data. Both of our inputs are in hours, but our output is a test score scaled between 0 and 100.
Okay, so one thing is, what he does is, these are like on a different scale than this is. So he wants to adjust the scale, so he just does some kind of transformation so that he adjusts the scales. Okay, you don't even have to do that, but it will improve the performance.
Neural networks are smart, but not smart enough to guess the units of our data. It's kind of like asking our model to compare apples to oranges, where most learning models really only want to compare apples to apples. The solution is to scale our data. This way our model only sees standardized units. Here, we're going to take advantage of the fact that all our data is positive.
So he uses this scaling. So what does this do? Let's say, what were those numbers that we had before? Let's take the hours that you study. So what were they? Hours that you study were here. Which ones? Probably here, right? Let's say these are the hours that you study. So 512. So if you want to scale this, you take the biggest number, which is 5, and then you just put everything over 5. So you'll get 2 over 5, 1 over 5, and 5 over 5. So now you're going to have everything between 0 and 1. Okay, so that's what he's talking about, scaling.
Before we throw our data into the model, we need to account for the differences in the units of our data. Both of our inputs are in hours, but our output is a test score scaled between 0 and 100. Neural networks are smart, but not smart enough to guess the units of our data. It's kind of like asking our model to compare apples to oranges, where most learning models really only want to compare apples to apples. The solution is to scale our data. This way our model only sees standardized units. Here, we're going to take advantage of the fact that all our data is positive and simply divide by the maximum value for each variable.
Okay, so here's some more Python. So there's that, we take x, we take our x vector, and we just, this means get the max of x, just a way of writing the max of x. So you just divide x by the max of x, okay? And that gives you your new x, which is the scaled x, okay? And you can do the same thing with y.
Effectively scaling our result between 0 and 1. Now we can build our neural net. We know our network must have 2 inputs and 1 output because these are the dimensions of our data.
Okay, so what does that mean? Why 2 inputs? We said because we're only talking about 2 inputs. The number of hours that you sleep and the number of hours that you study. Right? We could include lots of other things like what you had for breakfast or, anything else, right? How much coffee you drank, right? Lots of other things, but we're just doing 2 inputs, okay? And we're only predicting one thing, which is your grade. Okay, so you just have 1 output.
We'll call our output layer y hat because it's an F.
Okay, so this is called y, and this is called x, right? That's what we said, right? Okay, so we're going to put in x, we're going to get out a prediction y. Right? Does everyone understand that? Now, the reason that in statistics, whenever you put a hat on something, that means it's your prediction, it's not the real thing. Okay, so the real thing, we said, we don't expect that we're really going to get the real thing. Like our real grade was 89, but our prediction was only 62, so we don't expect this to be exactly the same as that. So we'll label this as, this one is y, the true value, but this is called y hat, the predicted value. Okay?
Estimate of y, but not the
So
same.
it's called the estimate of y.
We'll call our output layer y hat because it's an estimate of y, but not the same as y. Any layer between our input and output layer is called a hidden layer. Recently, researchers have built networks with many, many, many hidden layers. These are known as deep belief networks, giving rise to the term deep learning. Here we're going to use one hidden layer with 3 hidden units. But if we wanted to build a deep neural network, we would just stack a bunch of these layers together. In neural net visuals, circles represent neurons and lines represent synapses. Synapses have a really simple job. They take a value from their input, multiply it by a specific weight, and output the result. Neurons are a little more complicated. Their job is to add together the outputs from all their synapses and apply an activation function.
Okay,
Certain activation functions allow...
I said that we're going to use an activation function, right? I didn't call it that, but this is the activation. This is called, we're going to put it through some extra function, right? That's what I said, which is going to squish it between here and here, right? So that's called, in this discussion, called the activation function. Okay, there's lots of different functions we could use for this, okay? But we're going to need one of them, need something. Okay, so this is the function that they are using here. This does exactly that. This is an SCurve. Okay, so you put this number 29 into the function and you get something out. Okay, right? That's what we said, right? We're going to put in 20.